DevOps Quality with Steve Smith.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your humble host. Make sure you check out www.azuredevops.show for past episodes and show notes. And a few announcements. My latest book, .NET DevOps for Azure, is available, and you can get it now at bit.ly/.NET DevOps book. That's bit.ly/DOTNET DevOps book. And the ebook at bit.ly/.NET DevOps ebook. And there's also a special offer for user groups or conference leaders. If anyone is speaking at those community events, and for those in-person events, if you're organizing or speaking, I'd love to send 2 copies of the book, 2 print copies of the book for you to give away. And to request those, go to bit.ly/.NET DevOps book for community. And the book's available now, even as the publishing company is finalizing it for distribution on Amazon and other places. And I'm working on a .NET Core 3 edition to put out at the end of the year as well. So lots of work to do. But now let's get on to our show. Steve Smith has been recognized by Microsoft as a most valuable professional since 2002, and he is our guest today. He has a number of courses available on Pluralsight on software quality and mentors motivated developers at devbetter.com. He also shares tips on his weekly devtips.com podcast, and he blogs at ardallas.com. That's ARDALIS.com. Steve, welcome to the show. How are you, sir?
I'm doing great. How's it going, Jeffrey? Glad to be here.
It's good. It's good. And you've spoken and done so much stuff that probably most of the listeners have heard your name somewhere. But for those not familiar, you and I met crossing paths back and forth. Did we actually meet crossing paths back and forth to Iraq or somewhere around that time frame?
Yeah, we met virtually in 2004 as I was getting ready to go and you were coming back.
Yeah, and now you and I are both out of we're done with our Army Reserve life at this point, but that was a pretty interesting time.
Yeah, definitely was.
We both have our fingers and toes, but thank you, sir, for your service.
Thank you as well.
Now you've been doing software for a long time.
Yes, I'm old.
Then. No, we are the proper age, sir. But we'll get into what you're working on today. But there's so many. I was about to call them new kids getting into development, but there's so many young people getting development. And the industry is growing. It's exciting, and they all have their own story. But how did you know that you wanted to do this as your day in and day out work for your career? Was there a point where you were absolutely convinced?
I'd say in college, coming out of high school, I was into science and physics, and I wanted to be a physics major in college. And about my second year in college, I was double majoring or trying to double major in comp sci and physics. And physics got really hard, whereas comp sci was just fun and relatively easy. And I looked at like potential jobs after college, and you really couldn't do a whole lot with a bachelor's degree in physics, but bachelor's degree in comp sci, and you had a job easy. Like this was the late 90s, it was the .com boom. So, that kind of made it easy for me to make that decision and say, you know what, I'll just do the software thing full time, and ended up majoring in computer science engineering and got a job as a consultant right out of college, and the rest is history.
Nice. Now, I think you've done some speaking on domain-driven design and other topics and software quality, but you're doing a lot of work today specifically focusing on the quality aspect in DevOps, which of course would fall into the second way of DevOps, which is feedback. Why is that important? Are people missing that focus?
Well, I've always been interested in software quality. It's something I've done a bunch of courses on and spoken about. And continuous integration used to be this, practice that almost nobody had heard of, much less was doing. And now it's just something that's expected, and that's a key part of DevOps. And that just all by itself improves quality because it reduces those feedback loops. But there's more than just doing a build that you can do with CI, obviously. Most of your listeners know. So you can do tests, of course, but then there's also static analysis that you can run. There's code coverage checks and all kinds of quality checks that you can embed into that automated build process so that at some point that you could have enough confidence that you could just continuously deploy your product as well.
Okay. So as people are thinking about quality, and you mentioned continuous integration, so everyone knows in DevOps, okay, I need to build. And okay, I need to automatically deploy my stuff. So what are the quality techniques that people should be thinking about?
Well, one of the key things to me that I look for code quality, independent of DevOps, is just checking whether or not the code is testable. And one way that you can verify that it's testable, obviously, is to write tests for it, unit tests. But also you can usually just evaluate it, and if you know what you're doing in a statically typed language, you can look and see, like, does it follow the solid principles? Is it tightly coupled all over the place to data access technology or UI technology? Those things tend to make testing much more difficult. And as long as you have code that is testable, anyone that knows how to write tests can pretty quickly add tests to verify its behavior. And those tests then, if they're maintainable, will make it so that the code can change quickly and you'll catch regressions quickly. Even if you don't run the test suite yourself, you'll be able to have them have the build system catch those problems for you. The other thing to look for from a static analysis perspective, and we'll talk more about this, I think, in a few minutes, is look for business complexity in your code. And you'll usually recognize this by the presence of a lot of if statements or switch statements, what's called psychosomatic complexity. And so you can run tools that'll measure psychosomatic complexity. And those are the places where it's probably the most important that you have test coverage, because that's where the really gnarly problems in your application are going to be found.
Okay, so you threw out a lot of concepts there, and if you've been working with those things for years, like, oh yeah, this is what you do, but for people who are for people who are kind of coming into this new or haven't heard some of those buzzwords, maybe we can break those down a little bit. You mentioned something called solid, and I don't want to assume that everybody knows what that is. So how can people find that out? What is that?
Well, it turns out that I have a course on Pluralsight on solid principles of object-oriented design, but I didn't invent the term. Solid's an acronym that's been around for a while. Uncle Bob Martin writes about it quite a bit in some of his books. It's a set of 5 principles that you can use to write better object-oriented code. So if you're doing Java or C#, solid is definitely something you should at least know about and probably practice, or at least know when you shouldn't practice it. And real quick, they are the 5 principles are single responsibility, open-closed, Liskov substitution, interface segregation, and dependency inversion. And of those, I'd say dependency inversion probably has the biggest impact on the testability of your system.
Okay. And you mentioned the Pluralsight course. What's the title of that they can search for?
I've actually got 2. I think one of them may not show up in their search results anymore because it was older and they retired it. But there's Solid Principles of Object-Oriented Design is the original one from like 2012. And then just this year, I updated it with a shorter, streamlined one that's called Solid Principles for C# developers.
Yeah, those topics really, they don't age. They don't become obsolete.
No, Pluralsight just wanted me to update it because of the fact that it was using like Visual Studio 2010 or something, and it had their old logo and stuff in it.
Ah, the marketing people using the old logo can't do that.
That's right.
Okay, so we want people to think about quality, and if the team is using code reviews and someone is looking at it, they're going to make some judgment. But you're talking about techniques that can kind of on an aggregate upon a larger body of source code quickly give us some sense if there's any quality issues. Now you mentioned testing and you also mentioned static analysis. Let's dive into testing first. What are and we're talking about automated testing, you mentioned, what are the types of automated testing that people need to be doing on their code?
So there's several different types of tests, right, and of automated tests. And I classify unit tests as being automated tests that just test like one unit of functionality. Unit might be like a method. And the unit test, one of the rules is that it can't have any external dependencies, right? So it should just run in memory, and it should just run pretty much your code, right? It could run a little bit of framework code, but it has to follow the rule that it doesn't have any dependencies. If you have a test and you're wondering if it's a unit test, if it talks to a database, or if it hits the file system, or if it sends an email or talks over the network, then it's not a unit test. All right, but if it only calls your code and then returns some result based on what your code does, then that's a unit test. Another kind of test is an integration test. An integration test talks to those dependencies, right? So it might talk to a database and verify that a record got written correctly, or it might do the same thing with a file and make sure the file is correct. Then you have functional tests, which are a term that's often used for sort of full stack tests of the system that don't necessarily drive the user interface, right? They aren't necessarily done through the browser. So a lot of my work I do is ASP.NET Core, and you can easily write functional tests for ASP.NET Core controllers or Razor pages or API endpoints that run the entire stack and run all of MVC in an in-memory server, but they don't actually talk over the network. And depending on how you configure them, they might not actually even talk to a real database. But they do exercise the full functionality of that application, except for the client side, right? They don't run the browser. And then the slowest and most brittle tests, but still important in many cases, are UI automation tests using something like Selenium or Cypress. And what those will do is actually click on buttons on the page and type in text into text boxes, and then verify that text appears on the resulting page after a button is clicked or something like that.
Okay. And so for each of these types of tests, for people, they always, if they're not doing this, they're always saying, okay, what tool should I use? And so which ones are your favorites? If people aren't doing it, what tools, what frameworks do you love the most and reach for the most often?
I typically use XUnit for everything on the server side with .NET and C#, at least for .NET Core. If I'm working on .NET full framework, NUnit is still pretty much the standard there. But XUnit is definitely a good choice if you're using Core. It has a few advantages over NUnit, and it also happens to be what all the .NET Core framework stuff is tested in itself. And so every time .NET Core comes out with a new preview release, like as we're recording this, 3.0 is getting ready to go to production, all of their tests are written using XUnit. And so the author of XUnit works very closely with the ASP.NET Core team and makes sure that that tool works with .NET Core. And so it's a good bet to stay on that one. Whereas NUnit still works with .NET Core, but it may not be ready quite as quickly as XUnit is. Then for some of the browser-based testing, Selenium or Cypress. Selenium is something you can run from XUnit. Cypress is a JavaScript UI automation tool. I haven't used that quite as much, but I have seen that in use as well. And I usually use Jasmine and Karma for client-side testing, if it's an Angular app or something like that, to run those tests.
Ooh, Jasmine and Karma. Client-side web or client-side like WPF, WinForms?
Client web, so like a JavaScript Angular single-page application or SPA, so you can verify that the application that's running in the browser is behaving the way you expect.
Okay. All right. So you're big on test coverage. So what's your favorite method for figuring out if a section of your application doesn't have enough code coverage?
There are a bunch of tools for this. So if you're using Visual Studio and you're in the Microsoft stack, you can run test coverage directly from that tool. You can also use tools like Coverlet or Report Generator is one I'm using right now that has some nice features. And we can put the URL to that in the show notes. But basically you just want to be able to run something at the command line, ideally, because we're talking about automating this, that will generate a coverage report. And usually these coverage reports are in one of several standard formats, typically XML, and then you can read those reports and generate pretty HTML reports, or just pull out a number and do a pass-fail on your build. Okay.
And how do you think about test coverage? Do you actually fail your build on a test coverage result?
It depends on the client for the most part. Some of them have existing rules in place. So I'm thinking of one client that I've been working with for a while, and they have a legacy rule they've had for some time that is their test coverage has to be at least 80%. Right? So they're not striving for 100, but they have some minimum bar that they've set. I don't always do that, and the reason is that sometimes that ends up with developers just writing tests for the sake of driving up the coverage, and they might not be useful tests. For example, you might write a bunch of tests that verify that auto properties work. Right now, it's possible to exclude those types of things from your test coverage, so that you're less likely to have to do that sort of thing. But if you haven't set that up right, it's an easy trap for developers to kind of gold plate their code by saying, "Oh, look, I did this check-in and I increased code coverage by 20% because I made sure every getter and setter worked." Like they're part of C#, they're going to work, right? Let the .NET team test that.
So on one team that I was on, one of the engineers did something really clever, and I've tried to do it ever since. Was they just created one test that looped through the assembly via reflection and found everything that could be constructed with no parameters, every class that could be constructed with no parameters, and then iterated through the auto properties and just automatically tested them so that automatically every class that could be constructed with a no-arg constructor had auto properties as a means to say, you know what, let me do this thing. And then when a human's actually writing a test, we don't even think about that because it's already done. Sure.
And if you were doing that would not be a bad way to go. It's just if they were writing those manually, then that's just extra code you've got to maintain, and it's not really adding a lot of value. Now, something that you might want to test, for instance, could be that, let's say you've got a class and it has a property that is a collection. You might want to verify that when you create that class, that collection's initialized, so you don't get that null ref as soon as something tries to add something to it.
Yeah.
That's a pretty common error. But usually you run into that as in the course of writing your code, right? You can't do anything useful with that collection if it's not initialized. So,
okay.
So there are some cases where those tests can add value, but unless you're automating them like you described, which is a good idea, they're not usually something that I think adds a lot of value for the extra code that you end up writing.
Sure. Yeah, especially with auto properties, because it's pretty much built in, even if you're not even using a backing field.
Exactly.
Now, how do you cover the instances where a certain section of code may be 100% covered, but then another section of code, you may have a namespace that's close to zero? Do you fetter out different test coverage numbers for different assemblies or namespaces, or only look at the aggregate?
I usually just look at the aggregate. I do want to exclude some namespaces and assemblies, like the test assemblies. Typically, you have to manually exclude those, otherwise they'll be included in your code coverage results, which throws them off, depending on how you run the tool to generate the coverage. UI code tends to be the hardest to cover, at least with just plain unit tests. And that's one of the reasons why you want to put as much of your business logic outside of the UI as possible, because that's the thing you really want to get code coverage on. And then the other thing to keep in mind is that most code coverage tools just check whether or not a particular method was called or a particular block within a method, like, inside the if versus inside the else, whether or not each one of those blocks was executed by some test. But if your cyclomatic complexity, and we should probably talk a little bit more about that term in a moment, if you have a method with a cyclomatic complexity of like 10 and you've managed to hit, just the separate blocks with one test each, you maybe don't have proper coverage, right? You need to be able to test every different pathway through that method to have confidence that it's working correctly.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Well, let's talk about that, because we've been talking about testing a lot, which is a great quality technique. But then you also mentioned static analysis generally, and there's multiple types of static analysis. But how do you think about that concept, and how do you work it in?
So static analysis in general?
Yeah, you mentioned psychosomatic complexity, which is one of the metrics that's pretty common. But for people that are, okay, I've heard static analysis. What the heck is that?
Yeah, so static analysis is where you have a tool that looks at your source code or looks at your compiled assemblies, and using reflection or whatever technique is able to identify potential problems with that code. For example, maybe you realize that having more than, let's say, 10 parameters to a method is getting a little bit out of hand and probably indicates that that method could be refactored. Right? So you could create a rule, or many tools already have such a rule, that says that there's a certain limit to how many arguments a method should have, and if you find any method in my code base that has gone over that limit, then I want you to create a warning, or I want you to actually create an error and fail the build. And so, a tool I use quite a bit is called ndepend, which is a very nice tool. You can integrate it with Azure DevOps or with whatever build server you're using. I've got clients using it with TeamCity, for instance, and it has over several hundred rules, I think, if not thousands. I think just hundreds of rules out of the box. Yeah, and you can tweak them, you can configure them, you can say which ones you want to use or not. But out of the box, it has rules for things like that, right? So it'll say, hey, if you have more than 5 parameters to a method, maybe that's a warning, and if you have more than 8, then maybe that's an error, right? And then you can adjust those thresholds to suit you. But then if you use all those rules, they'll guide you toward writing better code is the idea. Now, coming back to psychosomatic complexity, what that refers to is literally how many different pathways there are through your code based on conditionals. So if you just have a piece of code that's a method that says, if the argument that was passed in is null, then throw an exception. Otherwise, return the argument plus 1. Mm-hmm. All right, super simple method. Well, there's basically 2 pathways through that code. Either it's going to throw an exception, or it's going to return the argument plus 1, barring some unforeseen other exception case. So its psychosomatic complexity would be 2, because there's 2 ways to go through that code. As a general rule, you want to keep your psychosomatic complexity for a method under about 10. And that's, if you just do a search on Wikipedia for psychosomatic complexity, you can read about it there. And there's been some studies done that kind of back that up. If you get up to between 10 and 20, that's pretty complicated code. And if you go over 30, it's really difficult for anyone to know what the heck that function is doing. And I've got clients with code that's got psychosomatic complexities of like 300, and obviously those are a joy to work with.
Now, are you saying on aggregate across the whole code base 300, or would you say within a few code files?
No, it's a good point. If some tools will measure psychosomatic complexity and roll it up per class, per project, per namespace, psychosomatic complexity really only makes sense at a method level. So I'm talking over 300 for one method.
So an average.
300 different ways. No, not an average. Like specifically, there are 300 different ways for one method to execute. There's that many if statements and switch statements in one method.
All right. So for those who are not measuring their psychosomatic complexity, what would a method that hits 300, what would that look like?
It's probably several hundred lines of code long. It might have some switch statements. It might have some nested loops. And it'll have a whole lot of if, else in it typically. And basically every time you have a branch like that, where you have an if or an if else or a switch, you're adding to that psychosomatic complexity number.
All right, so you're scrolling for days and you still haven't hit the end of the method.
Right. Yeah, and without debugging and stepping through, you probably are not going to be able to quickly determine what the heck is happening when this method is called. And that's where this metric helps, because if it's kept below 10 for any given method, then it's pretty easy for you typically to see it all on one screen at once, because it's going to be fairly short typically, and understand what it's doing.
Okay. Do shorter or longer methods have any correlation with better psychosomatic complexity?
Not necessarily, but generally, yes. I mean, if you have a high psychosomatic complexity, you almost have to have a lot of lines of code. But you could write a really, really long method that just did one thing, right? And didn't have any if statements in it. So there's that. The reverse is not true.
All right. So what do people do then? If let's say they grab ndepend and they start measuring and they're looking at these numbers and, oh, Steve said more than 30 is bad. Okay, then what should they do?
Sure. So more than 10 is bad, but more than 30 is like crazy bad. What they should do is they should refactor. There's all kinds of refactoring techniques. I go through a bunch of them in another one of my Pluralsight courses, Refactoring Fundamentals, that folks can check out. It covers a bunch of different code smells. The easiest refactoring for getting a big method smaller is to extract out methods from it. So, if you look inside your method and there's like different logical steps happening, pull out each logical step into its own method. And that parent method is going to start to get smaller, and each smaller method you pull out is going to be more focused and easier to understand.
So a lot of people say it depends, and I kind of hate that. But somebody a long time ago, and I can't remember who told me this. You mentioned extract method, and they said, if you see a block of code being commented, that's screaming for an extract method. What would you say about that?
Yeah, if there's a comment above the block of code, like you've got this big method and there's a comment that says extract, and then there's another comment that says transform, and there's another comment that says load, and between each one of those comments there's 30 lines of code. Well, you could have an extract method and a transform method and a load method, and now those comments don't need to be there, right? Because you could just use those as your method names. The other thing that is a big code smell is regions. I'm not a big fan of regions generally, but where they're really evil is inside a method. If your method is so long that you have to put regions in it, then that's definitely a sign that your method is too big.
I like those types of rules where people really just getting into software could say, okay, always do this. And when we say always, we mean greater than 90% of the time do this. That's a good one.
Right.
If there's a region inside a method, extract method so you can get rid of that region.
Yeah, every
That's
time.
Good. Okay. I've heard of this other pattern called replace conditional with type. Is that
With polymorphism?
Yeah.
Is usually how I hear it.
Okay.
Yeah.
Is that a good one too? What is that?
Sure. So replace conditional with polymorphism is a refactoring. It's another one that I think I talk about in my course. If I don't, I really should have, but I'm pretty sure I do. And basically the idea here is that instead of having a big conditional statement like a switch or something that is checking what kind of thing you have, like let's say you've got a user object, right? And so user has a type property that's a string. And so inside your code, everywhere you're doing stuff with user, you've got some switch statement that says switch on user type, and if the user is a manager, then do this, and if they're an employee, then do that, and if they're a customer, then do this other thing. Right, so now you've got this switch statement, and you've got a bunch of these switch statements because there's a bunch of different places where you need to do different behavior based on what the user is. Replacing conditional with polymorphism would be, instead of having user as just the only type that you know about, create a method on user that does whatever the thing is you're trying to do. Let's say you're trying to print the user's details, right? And if they're a manager, you need to print different stuff than if they're just an employee than if they're a customer. Okay, so you create a print method on user, and then you could create separate subclasses that are manager or employee or customer that inherit from user. They override print, and they do the right thing, right? Now, there's no if statements there at all. And inside the original method where there used to be this switch statement, and you'd say, well, if the user is this, do one thing, otherwise do another thing. Now all you have to do is say user.print, right? And it's polymorphic because that user in that context can behave as whatever type it might be, right? Whether it's a base user or whether it happens to be a customer or a manager or an employee. Now you're leveraging this object-oriented practice of polymorphism to eliminate the need for that conditional. And if you do it right, you're probably eliminating that conditional not just from that one place, but from many different places in your application.
Now, on a macro scale, if that way of thinking were adopted, it sounds like there would be a lot more code files than when you started. Is that true?
It's true, certainly, that if you follow the solid principles, and also if you do create more types generally, that you're going to have a lot of smaller files. And that's true if you have methods that are really big, psychosomatic complexity. Those big methods, almost by definition, are living inside of big classes. And so those classes are probably doing too much. And so when you start breaking up those methods, you're probably going to also be adding classes. And so you're going to have more files in your solution, for sure.
Okay, but you had a solution with a few projects, and each project had a manageable number of code files. And now you're talking about greatly increasing the number of code files. Isn't that making it more complicated?
Not necessarily, because what are you working on?
I'm being sarcastic, but
I know you're playing devil's advocate, but I do hear that argument, right? There's developers that have been writing code for years, and they're comfortable with the mouse wheel, right? They're comfortable scrolling as much as they need to scroll inside of a file to figure out what's going on. but they're not as comfortable with jumping around inside the tree structure of their project to find different places where something might be defined. And that's just a matter of developing that skill. Right? It is a different skill to be able to quickly navigate around a code base that's comprised of a couple hundred small files instead of a code base that's got 10 really big files. There's tools, whether it's Visual Studio Code, or whatever, Eclipse if you're coming from Java, they have code navigation features. You just need to make sure you're comfortable and familiar with them. And once you are, it's very quick to jump around and find where you need to go.
Yeah.
The thing to remember, though, is that when you're looking at code and you're reading the code and trying to figure out what it's doing, it's almost always going to be a lot easier to do that when you're looking at one class that has, maybe 1 to 3 methods on it that are all closely related, and each one, is less than 10 lines of code, right? It's going to be really easy to see exactly what that class is doing. So if it's not working, or if you need to write a test for it, it's going to be trivial to do so. Whereas if you have one like God class that does everything and it's 10,000 lines long, it's going to be much more difficult for you to quickly understand, what does this class do? It does everything.
Okay. All right. So we've been talking about static analysis. You mentioned independent is your favorite. Are there any others that you use regularly as well?
Probably just the one that's in Visual Studio, I would say.
Okay. The Roslyn that replaced FX Cop.
Yeah. So there's built-in Roslyn rules in Visual Studio. There's also Visual Studio analysis. So depending on which version of Visual Studio you have, you may have an analyze menu item that maybe you've never run, and it'll do something called calculate code metrics. And so you can say calculate code metrics for solution, and it will generate a few different things for you, one of which is psychosomatic complexity, but also it will give you a Microsoft maintainability index. It will tell you class depth of inheritance, lines of code, and class coupling. I think are the 4 things that it has, plus the maintainability index.
Okay. And do you run these with every continuous integration build, or do you have a separate process?
It depends on the client. I won't necessarily run them with every build. I have clients that do that, where the end-depend rules in particular are built into the build. The Visual Studio code metrics, there might be a way to automate that, but I don't have that automated into any builds presently. I'm not sure if that's something you can do without installing Visual Studio on the build server. But the end-depend, certainly you can set up the rules like I described so that they can warn or fail the build. And so I definitely recommend that. A quick note on Visual Studio's code metrics, if you use that, just be careful because the psychosomatic complexity, it won't let you easily sort it in Visual Studio because when you say, show me the biggest one, it includes all the projects and assemblies, and so they'll be at the top. I already mentioned that psychosomatic complexity doesn't really matter at the aggregate level like that. So what you can do is you can export it to Excel and then filter down to just members, which will be methods. And then you can sort on that, and that's a quick trick to see which methods have the biggest complexity. Okay.
Would you say that there's any rules of thumb where, hey, you know what? You should fail your build on a particular metric with a particular threshold. Is there any one of them that rises to that level?
Yeah, I mean, there's lots of them that you could pick a threshold, right? Like a lot of times when companies are bringing me in, it's because they already have legacy code that they've introduced a lot of technical debt to. We should talk about that term. But it's taken them, 10 years or more that they've built this application, and it has a lot of technical debt now, and so they're trying to figure out how to manage that and move forward. And so when you're in that type of scenario, what you want to do is create rules that will allow the existing code to pass the build, and then slowly kind of tighten the screws on it. So if you run the rules and you find out, okay, well, there's a default rule of methods shouldn't have more than 8 parameters, and you run it and there's there's 10 methods that have 10 parameters, and so it's breaking. Well, then you set it to 10, right, and then that allow it to pass, and then you try and fix those, right, and you slowly get it down back to where it should be.
Okay, awesome. Well, this is a huge amount of information, and for those who aren't not already familiar with these terms and whatnot, I'm sure that they're going to find your Pluralsight course pretty interesting. Are there any other books or resources that you would recommend someone go to if they want to learn more about this now? I
think the best resource I can recommend for writing better code is Clean Code by Robert C. Martin, Uncle Bob Martin. That one, along with Code Complete, are probably the two best books on just the way to write solid quality code. Other than that, I do have a bunch of different Pluralsight courses. We talked about a couple of them. Another one we haven't mentioned is on design patterns. A lot of design patterns will help you solve problems in more elegant ways that produces more quality code. So recognizing those design patterns can be useful as well. But I realize we're about out of time, so maybe we can talk more about some of those topics another time.
A lot to talk about. And what's next for you?
I'm still independent software developer and have a small team that I help companies and individuals write better code. So that's kind of my thing. As far as content that I'm working on, I'm doing a lot of stuff with Azure these days, and my recent talks are on like cloud design patterns. Just co-authored a book for Microsoft on Azure cloud development, and looking forward to doing more stuff with Azure and ASP.NET Core 3 coming up around the corner.
So you've published some recent books and given some recent talks. Where can we point the listeners to?
Well, go to ardallas.com. I've got links to a lot of resources there, including my podcast. I do have a book that I wrote for Microsoft a couple years ago, and it's being updated with each new version of .NET Core. It's called Architecting Modern Web Applications with ASP.NET Core and Microsoft Azure. It's a very long title. But if you just do a Google search for eShop on Web, you'll find the GitHub sample application. It's a reference app for building ASP.NET Core applications using best practices for Core. And that's something I've been working with Microsoft on for a couple years now.
Nice.
The book is free. It's a free ebook.
Well, how are you going to make money with that? No, I'm kidding. So, so many conferences and other user group appearances. Is there anything on the immediate schedule?
I'll probably be at Dog Food Con in Columbus, which is a Microsoft-oriented conference in October, and then I think it's November. I'll probably be at Dev Intersection, which will be in Las Vegas. Pretty much a regular there, and I have a workshop that I'll be doing on ASP.NET Core and domain-driven design using .NET Core 3 this fall, hopefully.
Nice. Yeah, it's coming out fast and furious. The frameworks don't stop. It keeps it exciting. All right.
Exactly.
Well, this is a great topic for our listeners. I appreciate your time, Steve. Thanks for being with us.
You bet.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.